In the second part of the double today, we'll look at true bearings. So the true bearing to a point is the angle measured in degrees in a clockwise direction from the north line. So always referenced from north. All true bearings are measured in the horizontal plane, and 3 digits are used to give a true bearing. So 65-degree true bearing would be written as 065 degrees. Okay, I don't know, just convention. Okay, so here is a couple of examples. So imagine I'm standing here, and this is like a bird's eye view of what I'm looking at. So I'm here this is the location of my house at exactly this point here. And at point P, what we've got is a palm tree. All right, so I'm heading from my house to look at this rare palm tree that's located in one of the residences down here in lovely Mulgrave. All right, so what I know is that to get to point P from where I am, I would have to follow, excuse me, a bearing of 65 degrees, okay? Because again, it's measured from north. So basically, I'd imagine standing facing direct north or true north, and then I would turn 65 degrees, and it's always going to be turning in a clockwise direction when I measure a bearing. So always turning clockwise, and then once I've turned 65 degrees in total from north, I can head off, safe in knowing that eventually I will come into contact with the palm tree. Now this is obviously as the crow flies, not physically, because obviously that might mean I have to jump a few fences or whatever it is to get to point P. This is as the crow flies. All right, now just say at point Q is the cafe and I want to get my morning latte. All right, so what I would do is, again, I would be facing north, 0 degrees. What bearing would I have to follow to get my morning latte? Well, what I would have to do is, starting at north, I have to turn in a clockwise direction. Now, I know this sounds silly. Like if I want to get my latte, I just start here, turn directly to that point Q and hit it. Go get my latte. But this is bearings, and we need a common reference point. So we always start at 0 and start rotating. So I'd go 90 degrees, 180 degrees, 270 degrees, and then a 30-degree turn more to get to facing this direction here, to direction Q. And then I would set off to grab my medium latte. All right, so this basically tries to, or attempts to sum up that. Note, a true bearing is used to represent the direction of one point relative to another point. So here's a couple of examples. The true bearing of A from B, so it's very important to note we're going from B. So this first one means from B to A is 65 degrees true. So if I'm starting here and I face north, if I want to get to point A, I would follow a bearing of 65 degrees. Okay, that's what I'd have to turn to get to point A. Conversely, if I was at point A and wanted to get back to B, or the true bearing of B from A, so from A get back to B, what I would do is go on a bearing of 245 degrees true. Now, how do I know what that is? Well, the way to work that out is to imagine this like a right angled triangle. So here's my right angled triangle. This is 65 degrees here. Okay, so this would be 90 degrees, obviously, and this one is going to be, I can't believe I'm doing this, but I've got a mental blank and I feel like if I don't work it out on the calculator, I'm going to make a mistake. 180 take away, that is 25 degrees. Okay, that's slightly embarrassing, but I don't care. All right, so that's 25 degrees there. All right, so how far am I going to have to turn? I'm going to have to turn 90, another 90, and 90 take away 25, which is 70, 65. All right, so I'm going to have to turn 90 plus 90 plus another 65-degree turn, and then I'm ready to go. Okay, and that's 180 plus 65, which, surprise, surprise, is 245 degrees. So that's how far I'm going to have to turn if I'm starting at A and I want to get back to B. All right, so here's some more examples. To state the true bearing of the point P from the origin in each of the following diagrams, and state the true bearing of the origin from point P. So 2 different questions. That's a different question. Okay, so in the first instance, we're going from the origin to point P. So from this point here to point P. So this one here, 1 is going to be 48 degrees or 048 degrees true. Right, this one here is going to be from the origin. I'm going to have to turn 90, another 90 plus 60. So that is going to be 180 plus 60 is 240 degrees true. All right, this one here is going to be 90 plus 40 removed from 90 is 50. That has to be 50. So that one there is going to be 90 and 50, which is 140 degrees true. All right, finally, this one here is going to be 90, 90, 90, plus another 20 is going to be, why am I labeling them like that? This is also 1, this is also 1, this is also 1. All right, so that's going to be 180 plus 270 plus 20, 290 degrees true. All right, now let's do part 2. Now this is the harder one. All right, so what we're doing is now we're here at point P and we want to get back to the origin. Let's say for argument's sake that I've headed to point P and I get there and I realize I've forgotten my wallet. Okay, so, and I don't know how to get back home. I need a compass to tell me. So the way to do it is to imagine a compass set up at point P. Now what am I going to have to do? I'm going to have to turn 90, 180, and whatever this amount is here. Now this amount here is going to be the same as this amount here, 48 degrees. Okay, now if you want to remember why, we've got 2 lines there, and back from year 8, maybe you measure this or you remember this. What we've got is a situation where if that's 48, that one there has to be 48 as well. Okay, the other way to think about it is, again, the right angle triangle, that's 90. This one here will be, and we've seen my ability to do mental arithmetic here, 90 take away 40 is 42. That's going to be 42, which means that this one here has to be 48. All right, so we're going to do 180 degrees plus 48 is 228 degrees true. The return is going to have to be 228 degrees true. Now there's rules governing this as well. There's like, if it's from here, then add 48 to 180. If not, do it from somewhere else. I don't know what the rules are. I just draw the picture. All right, this one here, what we need to do is from north, we're going to go back to the origin here. So that's going to be whatever this amount here is, okay? And we can see here that if that's 60, that's got to be 30. So this one here is going to be 030 degrees true. All right, we're here and we want to return to here. So it's going to be this, which is 90, 180, 270, 270 plus 40 is 310 degrees true. All right, lucky last, I'm here and I want to return to there. That means I've got 90 plus whatever this is. This must be 70 to make 90 degrees in total. So it's 90 plus 70, which is 160 degrees true. All right, second example. A bushwalker hikes due north from a resting place for 1.5 kilometers to a waterhole, and then on a true, okay, all right, stop. All right, let's draw this. So we're starting here, okay, this is, let's call this the resting place, and walks due north for 1.5k. So let's make this distance here 1.5, and then the hiker stops, okay, to a waterhole. So they're at the waterhole here, and that's 1.5. And then on a true bearing of 315 degrees for 2 kilometers to a base camp. So here's 90, here is 180, here's 270, 270 and 45. So that must be 45. So 270 plus 45 is 315. Let me just think about that. 30 and 15 is 45. Yep, that's right. And that's got to be 2 kilometers to base camp, 2. All right, so that's basically the journey of the hiker. So the hiker starts at the resting place, goes due north 1.5 Ks, and then starts north, turns 315, and then heads off to the base camp for 2 kilometers. Okay, so find how far west the base camp is from the waterhole to the nearest meter. All right, so how far west it is from the waterhole. So from the waterhole, this is the base camp. So what I imagine is this is how far west it is. It's this distance here. So the way I do this one here is I imagine a right angle triangle. I know that this is 2. I know that this is 45, and what I need is this measurement here. So I'm going to use some trigonometry to get it. Okay, so now what I've got here is the adjacent and the hypotenuse. So I'm going to use the cosine. So cosine of 45 is equal to adjacent over hypotenuse, a over 2. A is equal to 2 cosine 45. A is equal to, right, so I know that cosine of 45 is, what is it? 1 on root 2, but let's just work it out on the calculator. So we're going to go shift and 2 to get cosine. We're going to go 45, and we're going to multiply that by 1. Okay, so then what we're going to do is approximate that because we want it to the nearest meter. So it's 1.414. So A equals 1.414 kilometers. That's to the nearest meter, or you can convert that to meters if you want and say that that's 1,414 meters. Okay, but that is also an acceptable answer. Okay, let's do B. Find out how far north the base camp is from the waterhole to the nearest meter. Okay, so that is how far north it is. It's this distance here, which would be the same as this distance here. That's distance B. Okay, so our calculation for that is going to be very similar. In fact, it's going to be exactly the same answer. So this is going to be opposite over hypotenuse. So that's going to be the sine of 45 equals B on 2. And that's going to be B equals 2 sine of 45. All right, and B equals, so again, I just know a little bit more trig than you, only a little bit, and I know that this will return exactly the same answer because I know that cosine and sine are the same at 45 degrees. Times 2 gives us that. You're not expected to know that just yet, but you will soon enough. Okay, find out how far north the base camp is from the original resting place, correct to the nearest meter. So let's do that. That's C. So how far north it is from the original resting place. So that's going to be 1.5 and the distance we just found out, which is 1.5 plus 1.414 ... equals. All right, so all we're going to do on our calculator is jump over here and say plus 1.5 to that number is 2.914 kilometers. So that's to the nearest meter. Find the true bearing from the base camp to the waterhole. So base camp to the waterhole to the nearest degree. True bearing from the base camp to the waterhole to the nearest degree. So I want to go from the base camp to the waterhole. So that's going to be 90 and another 45 because that's 45 down here. So I don't need it to the nearest degree. I can give the exact answer here, which is 90 plus 45 equals 135 degrees true. All right, and E, find the true bearing from the base camp to the resting place to the nearest degree. So just say I thought, oh, I left my wallet over here. All right, so I want to go straight to there. I don't need to go back to the waterhole. I'm going to go straight to the base camp down here. All right, so this is hard. All right, and this is something that students will struggle with. So to do this, what I'm going to do is get you to imagine a right angle triangle drawn like this. All right, now what am I doing here? What I need to do is I know that it's going to be 90 plus whatever this angle here is will give me my true bearing to return on. So it's going to be 90 plus what looks to be about, 50 or 60 degrees or something like that. All right, so I actually then will redraw this triangle. So this is question E. So it's going to be a triangle as follows. All right, now what's this side going to be? Well, I actually worked that out earlier. That's this value here. It's 2.914 kilometers. And this one here, I also have worked that out. That's going to be the same as this value here. That's the first one I worked out, the westerly distance, which is 1.414 kilometers with a dot, dot, dot. So we're going to make sure that we use the exact values. All right, now what I want is this angle here. I'm going to call that theta. Okay, so we're going to say that in this case here, I've got the opposite and the adjacent. That's going to be tan. So tan theta equals the opposite, which is 2.914 dot dot over 1.414 dot dot. Theta equals the tan inverse of that. So we're going to go tan inverse. Now, here's the really important thing, girls, that what you've got to do is grab the most exact version of those numbers. So we want the one with all the decimal places in it. All right, we're going to check that we're in radians mode here because we need a degree calculation. And there it is there. It says it's 64.113 dot, dot, dot degrees. So therefore, the true bearing is going to be 90 degrees. So we're going to turn the original 90 plus the angle I just found, theta. So 90 plus theta, excuse me, that's going to be 90 plus this value here, which is 154.11 dot, dot, dot degrees. They want it to the nearest degree, therefore 154 degrees true is going to get me back to the base camp. Okay, this one does come out of Cambridge and it's question 14, I think. So it's worthy of having a look at and doing this one in class. The Cambridge textbook didn't include a diagram for this, and Mr. Tench, I think, kindly drew this up a few years ago to allow us to visualize the problem, but it's an extremely difficult problem. Right, so two groups A and B view a rock from different positions on a road leading east-west. So this is the road here, all right? And here is the rock. For some reason, I imagine like Uluru, okay? All right, so there's the rock that's being viewed from the road. So basically, if you imagine like we've got two bus tours or something like that, one bus tour stops at this point here and has a look at the rock, and another bus company here goes, oh, that's full, there's too many people there, so let's go down to point B. So they stop here. All right, so what we want to do, let's just fill in what we know. Group A views the rock at a distance of 235, so there's the distance, on a bearing of 155 degrees. True, that should say. All right, so what we're assuming is that then they would get to here. Now, mind you, this is not a bird's eye view. Yeah, it is. I think it can be considered a bird's eye view, yep. So that's north, remember, is 0 degrees. So I'm looking at it on a bearing of 155. So that's going to be 90 degrees and then an additional turn of 65 degrees to see the rock. So that'd be like you get out of the bus basically and the tour guide says, all right, everyone face north, 0 degrees. Now I want you to turn to a bearing or on a bearing of 155 to see the rock, all right? So you'd have to turn 90 degrees plus another 65 and then everyone would be looking at the rock, okay? So what they're going to do is it's going to be 65 from the road, another way of thinking about it. Or if you're facing east, another 65 degrees. All right, over here, let's consider the people at that get off on bus B and have a look from point B. So they view it on 162. Now that obviously they're going to have to turn a little bit further. So this should be a bit higher. And in fact, it is. It's going to be 72 degrees in this case, right? 90, yeah. Okay, so how far south is the rock feature from the road? Oh, find the following. No, I shouldn't have corrected Mr. Tench's work there. Find the following, rounding all answers to 2 decimal places. How far south the rock feature is from the road? All right, so south is going to be there, the distance from there to there. That's south, because if that's north, that's going to be south. All right, so how far south is it? Well, notice that that creates a right angle triangle. And what I'm going to do is use this big right angle triangle here as the basis of my calculation. So I've got 235, right angle triangle. I know that that's 65. And what I'm trying to find out is x. All right, so I can just use some trig on this. So I'm going to use the sine ratio. So that's going to be the sine of 65 equals the opposite, which is x over 235. X is equal to 235 times the sine of 65. Double check your calcs in degrees and go 235 multiplied by sine, which remember is shift 1. Seems reasonable. Therefore, 212.98 what are we, meters away from rock, okay, or south of rock, south from the road. Third attempt. All right, how far east the rock feature is from Group A? So the easterly distance will be this distance here. So we'd be looking for this one here. All right, so for that one there, we'll use, for part one, we'll use cosine, isn't it? Yeah, cosine. So we'll go cosine of 65 equals this, let's call it y. Y on 235. Y is equal to 235 times cosine of 65. What's it going to be? 99.315. Therefore, 99.32 meters. Okay, let's do the second one. How far east is the rock feature from Group B? So we want this distance here. Now, the only problem with this is that we don't have this distance here. But actually, what we do have is this distance here. So this one here, we're going to write in as 212.98 meters, remembering that it's dot, dot, dot. So we rounded that. We need to make sure that we've got the exact value. So this one here, I'm going to redraw the triangle so that I can see what I'm looking at. 212.98 dot, dot, dot. We've got a 72-degree angle, and what we're looking for, let's just call that Z. So here we've got opposite over adjacent, okay, opposite over adjacent, so that's tan of 72 equals 212.98 dot, dot, dot over Z. So that goes to there, that goes to there, Z is equal to 212.98 over the tan of 72. We no longer have that calculation in here because I overwrote it. So I'm just going to pop it back in. That's fine. So that's the exact calculation there. So I'm going to go and take that and divide it by shift 3 for tan of 72. Hit enter. And now I'm safe in approximating to 2 decimal places. So Z is equal to 69.20 meters to 2 decimal places. All right. Find the distance between Group A and Group B. So the distance between them is going to be the distance I worked out for the first part. That's this distance here. Take away this distance here. All right, so that's going to be 99.32 take away dot, 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 take away 69.20 dot, dot, dot. All right, now do I have 99 still in here? No, I don't. All right, that's annoying. All right, so now I'm just going to copy that and change that to cosine. That'll get me my 99. I'm going to grab the full version of that, take away the full version of this so that I don't get rounding upon rounding errors. And I'm going to get the distance of 30.113 dot dot dot, therefore 30.11 meters. All right, so there is the work there, girls. Bearings aren't easy. You've got to draw lots and lots of pictures, redraw triangles, etc., etc. Good luck with that.